Today we're going to finish up chapter 6, looking at trapezoids and kites. So using their properties to be able to work through some problems. So to start out, we have our properties for trapezoids. So you see we just have two properties. Okay, so trapezoids are not a parallelogram. So those shapes that we talked about in our previous section, the rectangle, rhombus, and square, all had those properties of parallelograms. Trapezoids are completely different. Okay, they have four sides, they're quadrilateral, but they do not have those properties of a parallelogram. So completely different properties for trapezoids. Trapezoids have exactly one pair of parallel sides. Okay? So just one pair, where a parallelogram has both pairs of opposite sides parallel. And then a key piece that we're going to be using is this formula that the mid-segment of the trapezoid is half of the sum of the bases. So base 1 and base 2 are added together and then multiplied by 1/2 or divided by 2. Then more specifically, we can talk about isosceles trapezoids. We've seen that word isosceles before with triangles. What is an isosceles triangle? Two sides are equal. So in an isosceles trapezoid, we have the same two properties that work for all trapezoids. And then we have three more properties that apply when they are isosceles. So if it's an isosceles triangle, the non-parallel sides, which we call the legs, are congruent. So that's where that word isosceles comes in, because we have those two sides that are congruent, the same length. The sides that are not parallel. In the isosceles trapezoids, we know that our diagonals are congruent. They are the same length. And the base angles, so our bases are those two parallel sides. Okay, we have base and we have legs. So the base angles are also congruent. So those are properties that we are going to be using as we take a look at some of these problems. So in example 1, we want to find the value of x. So I have a trapezoid because I know by looking at the arrowheads, I have one pair of parallel lines. Okay? This is not an isosceles trapezoid. My other two sides are not congruent. They're not marked congruent. I have information about two angles. How can I set up an equation to be able to solve for x? What kind of a relationship do I have with those angles? They are same side interior, which means they are supplementary. So 12x plus 3 plus 13x plus 2 is equal to 180. So I combine like terms. 25x plus 5 equals 180. So I subtract 5. 25x equals 175. I divide by 25 to find that x is equal to 7. So again, knowing that we have parallel lines is key in this unit because we know lots of things from first semester about parallel lines cut by a transversal that we can apply in this unit. In example 2, we are told that AB is 7y plus 6, EF is 5y minus 3, and DC is y minus 2. Again, we have a trapezoid, but it is not an isosceles trapezoid. This is where we're going to use that mid-segment formula. Okay. This segment EF that's going through is what we call the mid-segment. The top and the bottom, the two sides, are the bases. So using that mid-segment formula that you have listed up in your properties, it says that the mid-segment, 5y minus 3, is equal to 1/2 times the sum of the bases. So I'm going to add the y minus 2 and the 7y plus 6. So when I work inside my parentheses, I get 8y plus 4. I'm going to take half of that, or you can think of it as dividing by 2. Multiplying by 1/2 is the same as dividing by 2. That is equal to 5y minus 3. So now on the right side, I can divide by 2. So I'm going to get 4y plus 2 equals 5y minus 3. I'm going to subtract 4y. I want to get rid of the minus 3, so I'm going to add 3 to find that y is equal to 5. As always, you can always check your work. If I plug 5 back in here, that would tell me that DC is 3. It would tell me that EF is 25 minus 3, which is 22. And AB is 7 times 5 is 35, plus 6 is 41. If I'm going from 3 to 22, what's the distance between those 2 points? From 3 to 22 is how much? 19. To go from 22 to 41 is how much? 19. Okay, 22 is the mid-segment. It's in between, exactly in between the 3 and the 41. So that's how you could check your work with that kind of a problem. So that mid-segment formula, something that you want to be able to process. In example 3, we are told that DONE is an isosceles trapezoid. So again, that means that my non-parallel sides are congruent. We are told that the measure of angle EDO is 110 and DEN is 15x minus 5. We want to find the value of x. So I have 2 angle measures. What do I know about the relationship between those two angles? They're same side interior, which means they are supplementary. So they add up to equal 180. So 15x plus 105 is equal to 180. So I'll subtract 105. 15x is equal to 75. Then I'll divide by 15 and find that x is equal to 5. And again, if you wanted to plug it back in, you could to check your work. Example 4 says TRAP is an isosceles trapezoid. So again, I know I have parallel sides, and then I have the other two sides that are the same length, congruent. If PR is 3x minus 7, PR is 3x minus 7, and TA is 20. So they've given me information about the two diagonals. So what do we know about diagonals of an isosceles trapezoid? They are congruent or equal to each other. So I would add 7 to both sides. 3x equals 27. And then I would divide by 3 to find x to be equal to 9. So those are examples of working with that trapezoid. One pair, only one pair of parallel lines. And then the second shape that we talk about today is a kite. So you've got a number of properties there. I'll give you a minute to write those down. With the kites, again, completely different from the other quadrilaterals that we have talked about. When we take a look at these properties, kites have two pair of consecutive congruent sides. So when we think about a kite, consecutive sides are congruent. It has two pair. You just need to look at what would be those two pair. Our diagonals are perpendicular to each other, which means we have right angles at all 4 of those corners because they are perpendicular. The long diagonal, so the one that's vertical in my diagram, bisects the opposite angles, which we call the vertex angles. So up top and down below are what we call the vertex angles, and they have been bisected. So they've been cut into equal parts. The long diagonal is bisecting the short diagonal. So my short diagonal has been cut into 2 equal parts. The non-vertex angles, which are between the non-congruent sides, are also congruent. So when you look at that kite and all of its markings, if you were to take that kite and fold it on the long diagonal, everything is going to match up. Okay, all of those parts are going to be congruent to each other. Okay? So if you think of it in that respect, folding it on that long diagonal, it makes kites easier. You'll also notice when those diagonals are drawn in again, we see 4 triangles. And those triangles are right triangles. And so we can again use lots of information that we know about triangles. So a couple of examples that we're going to look at. In this first one, okay, we've got a kite. So if we look at which diagonal we could fold on, okay, we'd be folding on the yellow diagonal to make everything match up. And we have 5 different angle measures we need to find. So any of those 5, what can you tell me?
Angle 1, 90.
Okay, angle 1 is 90, because that's a right angle.
3 is 38.
Angle 3 is 38, because we're looking at that fold. We've got those corresponding angles.
5 is 53.
Okay, 5 is 53. 2 is 52, and how did you find that?
I subtracted 100, or I added 90 and 38, and I subtracted that from 90.
Good. So for angle 2, we've got the triangle. We know 3 angles in a triangle add up to 180. So angle 2 is 52. We can do the same type of process to find angle 4. So how much is angle 4? 37. This next one, okay, it's not showing the diagonal, but we can still draw that diagonal in. So we can see that fold. Okay. If somebody sees a different way that we could look at it, we can talk about that also. Okay. So, what could we do looking at our properties? What might help us find angle 1 and angle 2?
Adding 90 and 54 together and subtracting it from 180.
Can't subtract it from 180 because these angles aren't in our triangle after we drew in that diagonal. Okay, we need to put our phone away, please. Okay, so what can we do here?
You can divide 54 and 90 both by 2, add those together, and then subtract.
Very good. Okay, when you look at your properties, our long diagonal is bisecting the vertex angles. So half of 90 makes these each 45. Half of 54 is 27. Okay? So we can take that away from the 180, which leaves us with, pardon?
108, I believe. 45, 27.
Is 72, yep, so 108. Okay, same thing is going to be for the second angle. Okay. Anybody see something else we could have done to find angles 1 and 2? If I wouldn't have drawn in that diagonal, wouldn't have used the diagonal reasoning, just by looking at the picture given, is there any way we could have found angles 1 and 2? Because again, we do know that angle 1 and angle 2 have to be the same. What do we know about the sum of the angles in a quadrilateral?
360.
it equals 360. Okay, so if I would have called those x, okay, I could have had 2x plus the 90 and the 54 is 144 equal to 360, and could have worked it that way also and came up with that same answer. Okay, so different things that we can apply there. In this last example, so again, we've got that diagonal. We have that long diagonal that we can think of folding to match up our corresponding parts. We have both an X and a Y that we need to find. So if we start out with our X, when we look at X, we have two different angles. Up top, we have 3x plus 5. Down below, we have 4x minus 30. What do we know about those two angles? They are equal to each other. So 3x plus 5 equals 4x minus 30. So I subtract 3x and I add 30. So I find x is equal to 35. And then I also need to find y. So when I look, I've got y as an angle, then over on the opposite side, I have this other angle, which is 2y minus 20. Do I know any kind of relationship between those two angles? They are not going to be equal because they're not matching up when I fold. So they're completely different angles, similar to our first picture, okay, where I have the 38. Angle 5 was 53. Okay, so those are not going to be congruent. So what we need to do is we need to look at one of the triangles. Doesn't matter which triangle because they are the same. I'm going to take a look up at this top one. So I have this angle of y. Now that I know that x is 35, I can come up with a number. So when I take 3 times 35, I get 105. 105 plus 5 gives me 110. I know the third angle is also the 2y minus 20. So now I have information about all 3 angles. And I know that 3 angles in a triangle add up to 180. So I have angle y, I have the angle of 110, and I have the angle of 2y minus 20. Those 3 angles are going to add up to 180. So when I combine like terms, 3y plus 90 equals 180. So I'm going to subtract 90. 3y equals 90. Divide by 3 to find that y is equal to 30. So again, with these kites, find that line that would allow you to fold and match up all of those corresponding parts. And then also think about those triangles that are being formed, which also supply us with lots of information.